minerals form. We need a lot of energy, and it can be reasonable in economic terms if we produce the same amount of aluminium chlorine. Practically interesting becomes silimonate of aluminium chlorine without power consumption, with further hydrolysis and calcination by gamma alumina. At the same time, we should consider the fact that bauxite and nepheline, in terms of aluminium, are a little bit cheaper than silimonites and we can process silimonite ores, and for the modeling to understand the composition of silimonite group of metals, we can follow this sheet at a temperature of 1300 degrees. Initial ore or concentrate blended with hydro-containing reduction agent using chlorine and aluminium oxides after separation and cleaning. Using gaseous phase hydrolysis, we can produce oxides of aluminium and silicon. The production of silicon oxide and aluminium oxide in powder is process aluminium chlorine using carbochlorination. We used tetrachlorine for processing of hyaline ores. As a result of lab research, we identified that at a temperature of 1300 degrees Celsius during 90 minutes, the mix of kyanite concentrate with carbon over 60% of initial concentrate converts into gaseous phase. Chlorination at temperature of 1300 degrees becomes volatile of aluminium 3O2 and crystal light, and that's we needed to check chlorination of multization and to, to understand if there is any impact on chlorination of a sample. For, in order to chlorinate the sample at a temperature of 1300 degrees during 90 minutes, we achieved over 98% of chlorination. Multization, which goes alongside the chlorination, increases reaction of chlorination, and that's why you should have no concerns about chlorination of silimonite group minerals. Although the literature there was data published that the resistance of this substance is bigger than chlorinated. The same conditions. We managed to chlorinate only 4% of this concentrate, so obviously this process is not so cannot be used in production so easily. However, the data in published data says that this process can be used in order to use unconcentrated.
So we looked at 16% of aluminium oxide 84% of carbon, silicon dioxide, and titanium dioxide. So in 2 hours, for 2 hours at 1300 degrees, 78% was chlorinated. Over 78% of the kinetic quartz were chlorinated. And the experiment also showed the aluminum oxide and the silicon oxide in this mixture will be chlorinated at about the same speed. So if you're calculating to oxide, the composition was essentially the same. Tentatively, the experiment showed that this method of processing of kyanite ores is also good for bauxite processing, including bauxite with high content of iron oxide and silicon oxide. The temperature of reaction in this case may be reduced down to 1000